Today I'm going to talk about this 5G multi-access edge computing. We have from Mr. Raymond, we have the edge computing, and so we are now going to focus on this in this telecommunication area using the concepts explained by Mr. Raymond. So the main topics for today will be, as you can see here, introduction, concepts, MEC use case, the future, final consideration, and some final question at the end. First, I would like to start with this one. In this one, we have our wireless network. We have like different components in our network from core, going from core part here, radio access part here, devices. So in each part of them, we have like different technology or different names. For example, for 2G, we have something like the MEC. In 5G, we have the 5G core. We have the radio access with different name depending on the generation. We have different kind of user equipment with different features over there. And also we have the transport part composed by all the medias we have to transmit the data from the core to the radio part. And also we have the spectrum, from licensed, not licensed, sub 6G, and all of this spectrum we are using in the network. The tendency we have so far is like several of the functions that we were handling in the core part are trying to move closer to the end user, something called like the edge functionalities. And from the run functions, we are trying to process as much as possible of that very far away from the user side, close to the core. So as you can see here, core functions going to the user device and run functions going to the core. So we have like this cloud journey that have been seen from the servers, as mentioned by Mr. Raymond. And also we have this kind of evolution in the core part and also in the run part. We have this traditional to this virtualized area here, and then to the cloud and to the cloud native scenarios that we have presenting on this moment. So in the telecommunication, we're having like this evolution that let's gonna say in the server, they have it like from several years ago. And right now we're having, we like in the telecom area, we are having these scenarios, running today, with the run parts and also with the core functionalities. Here we can see like this kind of evolution. Let me do some zoom here. Like the classical network application we have from the beginning, like let's wanna say like 10 or 20 years ago, where we have a specific hardware with dedicated functions. So in our part, for example, in the part that I was working, for example, to define like a SGSN, GGSN in the core part, we have to define like all the boards, all the interfaces, and depending on what was on the other side, we define like different kind of connection. If it was fiber, if it was coaxial, or if it was like any other connection. So after that, we have something like this kind of evolution that this network function virtualization, that all these hardware specific or dedicated hardware, we have everything in a virtualized ecosystem with all the function, decoupling like from hardware and software. So no matter like whatever functionalities we have here, we can use essentially the same hardware and putting different kind of functionalities working over there. For example, switching functionalities, HSS functionalities, core functionalities, using this main virtualized concept or this virtualized ecosystem, using infrastructure like the server with all these memory, processing, and storage functionalities, having a host OS and hypervisor, and over there putting all of this virtual machine depending on what we want over there. So as you can see here, the main principle of this virtualized ecosystem are NFVI, like implementation or infrastructure of these functions, orchestration, monolithic because most of these functionalities were defined like from the beginning, and not so much flexibility to change or to use like or to grow. And also the stateful, like all the functionalities were related or were focused on only one devices here. So for this evolution from traditional hardware-based functionalities to virtualized functionalities in the core and also in the RAM part, we also have like this evolution or this evolution to cloud native. The main thing here, this cloud native is we're working with cloudified functionalities. You have infrastructure, you have a host OS, a container engine, and we have like these container functionalities in over this or over this equipment. So here you have all of these functionalities that you will have, for example, in the core or in the radio access, working in a container environment. I mean, all of the functionality, all the software necessary, for example, to have, like, for example, user plane functionalities in one of these containers. Like any other functionality, like I don't know, network slicing functionality was here, and so on. So all of these different functionality, for example, for the core or for the user plane, put it in each of these container. So for this, you use in similar way as you have with the virtualization, you have this code server or generic server, and over there you have like all of these container functionalities here. So the main principles here for this cloud native is stateless, is associated with microservice, intelligent orchestration, and efficient network functionality infrastructure here in this ecosystem. So one of the other things that we need, I mean, to realize about all of this is where is the edge. I think I took like this information in this source, as you see here. I will share anyway the link in the YouTube version of this presentation. And so as you can see here, depending on where you are working or depending on the sector you are working, you define the cloud, the edge, and the very edge in different areas. For example, here in the telco, I mean, in our particular sector of telco, we have the cloud located here in this part of the core. The edge located here between some part of the core, the radio access, and the on-premise servers, and the far edge on the devices that you have here on the gateway and on devices. But for example, if you are, let's want to say an hyperscaler like AWS, they consider the cloud, the edge, and the very edge like in different areas. So this one is just to have like the feeling about how is interpret the edge in different scenarios. In our particular telco, in our particular area of telco, when we talk about cloud, we are talking about the core cloud here, located here in this area, and the access and the edge located part of this core and on the radio access network, as we will see in the following slide. So we have like this definition of cloud computing. I mean, the cloud is a model where you can have like capacity of processing information like everywhere in this cloud. Sharing the resources to different kind of usage. Also, you have something, a definition called fog computing. It's not something, it's like a concept that was talked like, let's say a few years ago. Today, not so many people are talking about that. But anyway, something like a concept that we need to have in our mind in case somebody talk about all of this. So in general terms, the fog computing is a distributed computing infrastructure to have data, compute, storage, and application that are located somewhere between the data source and the cloud. In relation to the edge that we will see in a few seconds later, it has an additional layer of processing information and potential data aggregation before moving to the cloud. The edge computing is a telco and IT concept. It's a decentralized computing framework that brings the computation and data storage as much possible to the end user as possible. We have something called multi-access edge computing. It's essentially a telco concept that enables cloud computing at the edge of the cellular network. It's a MEC standard, or it's a MEC specification. And we have something called cloudlet, like it's a small cloud located in an office or in a company that is limited by a company. You have, I think it's better to see it like here. So here you have the cloud computing, focus on the processing on the cloud on the core. This fog computer also including some part of aggregation and data processing here before passing that information to the cloud. We have something like the edge computing, like this capacity of processing information as mentioned by Mr. Raymond here. And we have like this MEC that is, let's not say it's more or less like the edge computing mentioned by Mr. Raymond, but is focused on telecommunication and is defined by the ETSI specification. And also here we have this cloudlet, like is this capacity of processing information like in a company or in an office or in a university limited by this geographical area here.
For some time now, against the tide of centralized cloud computing, one idea keeps coming back. What if we could save data from having to travel thousands of kilometers when it is destined to come back to the same place? This is the idea behind multi-access edge computing. We call it MEC. MEC is like small, local clouds, physically installed as close as possible to the users at a mobile base station, for instance. The content from here is used here and stored here. This sounds obvious. However, it is this geographical proximity that makes it possible to imagine vehicles that transmit information to each other at the speed of light. Or factories lowering their costs by processing their confidential data on site. Or even gamers who can enjoy exceptional speed and great quality of play. Oh, of course, some might say, hey, but all this we already did before. Yes, but never so rapidly and securely. Ah, yes, indeed. Obviously, MEC technologies need to be standardized and therefore made fully interoperable. Hey! This is why, at ETSI, we have been working on standardizing this technology since its inception. All the players who are involved in MEC technology, closely or remotely, participate in the work done by ETSI on an equal footing. So, if you want to be where MEC brings edge computing into reality, join us.
I think like the best way to understand all of this is with this kind of video, or at least an image, to understand better all of this concept about MEC. So we have here like the evolution. Let me just here. Okay, we have here like this. Can you still see my slide, right? Hello.
Yes, Carlos.
Okay,
Yes.
thanks. So here we have like a little bit like how have been this evolution or this MEC history. I mean, we have from Mr. Raymond, like how was the edge computing evolution, or a little bit about the history about all of this. But this is in particular focus on the MEC history. MEC has evolved to support a different range of applications and services, a particular focus on 5G, and also has been included like for example services like Wi-Fi, like in this year. We have like this in 2014 the ETSI defined like this definition. They define like to work together to define like what was the MEC and how to work for all of this. In 2017, the ETSI changed the name from mobile edge computing to multi-access edge computing, because they add this part of multi-access to reflect like different or additional technology, including different access technology like wireless, Wi-Fi, and wireline access. But for our area, we are just focused about wireless and Wi-Fi. In 2022, this was this definition, the version 3, that is the one that we have available so far, and they are start working on the version 4 of this specification for MEC. So why MEC is necessary? Most of the benefits here, I think, were explained very well by Mr. Raymond. But here, in terms of telecommunication, we can see like a particular issue we have with the telecommunication and with the latency of the time that we need to process, or we have to process some information. For example, here, without edge computing, we have like devices and base station like to have like a very a small period of a very low latency, but we need to connect with the core, so we spend more time over there. We still need to connect to internet, to the regional connection of internet, 40 more milliseconds, and then we have to connect with the global internet. So without edge computing, like all the process that we were wanted to do here is taking like so much time to process. With the edge computing, we're trying to make this time as short as possible. I mean, to reduce the need to communicate with this data processing, like with less time. I mean, let's gonna say 10 to 30 milliseconds. Even though in 5G, we are talking about the terms of 1 or 2 or 3 milliseconds, but in general, this is like a good number to start with this latency here. So not all the traffic requires the same. Not all the traffic requires the same handling of information. As we have here, like the different clouds or the different parts of our cloud, the core, the edge, the end user, and the device here. For example, here you have, wow, okay. We have here that, for example, for general traffic, like the one of just storing information from our phones, of our pictures, I mean, we can just store it in the core. I mean, we don't care so much about how much time is taken to store that information. I mean, we don't care so much about latency here or data or amount. I mean, we just take a picture here in our phones and just wait for whatever time, and this data will be stored here in this okay. So and this information will be stored here in the core without so much problem. But there are some particular issue. For example, when you have a company, and that company has some private or confidential information, so that information cannot be stored like in a central core. So they are limited here on this area, in this edge area. And also there are some, for example, some regulation from countries. I mean, like this name of sovereignty, like, for example, that some information cannot go out from a country. So it's limited, for example, for Philippines, for Mexico, or for United States here. So for that reason, we need the process or the handling of this information as local as possible. So for that, MEC is necessary. There is another scenario, for example, where you are handling information, and for sure that information can be handled like in the core, in the edge, or in the very near edge here. But for example, to process that information here requires, for example, transmission from here to here. So you will need a lot of transmission. You will need to spend a lot of electricity to put that information here. You need to spend like a lot of money. If you store that information here, for example, in the edge, I mean, maybe you don't need like so much transmission, but you still need to store that information in some server that is a little bit far away. But if you have like that information stored here, something like near edge, like you don't spend like so much money like in the transportation. You don't expect like so much electricity to have like this small server here close to the end user. And for sure, you will spend like a few, like not so much money for that. There is like another point that was also mentioned by Mr. Raymond, is about some particular issue. For example, for security issues, that, for example, you are storing or you are watching like some information or some events here, like for example, like somebody stealing something or whatever for security, that you cannot spend or wait that all of that information to be processed here in the core. But you need to process that information as much as possible, as very fast as possible, like latency very reduced as possible, and take the decision about how to alert about this event, about this bad guy here located here. So for that reason, also the MEC is necessary here. And also for the autonomous vehicles mentioned also by Mr. Raymond, that for this, you have for sure like different sensors related to the car. But if you have, for example, like a kid playing around or close, and this car is moving here, you need to stop the car as fast as possible. You cannot wait like to take the decision back on the core, like to take like, well, I don't know, whatever milliseconds over there, but you have to take the decision as fast as possible. So this kind of application that is called V2X communication is also make necessary here. And one that is not like critical, I mean, because it's not like emergency, like for example, for the car, is for example, for the games. Because also for the games that for sure you are expert on this kind of games, you need like a very latency, I mean, to process, I mean, to push the button, kill the bad guy in the game. So this kind of application of gaming is also necessary to process the information here in the MEC, like very close to the end user. So as you can see here on this slide, you can have application like very close, I mean, far away from the end user because they are not critical, but there are some other application like industrial application, like for cost saving, for security issue also here for V2X, and also for gaming, that are necessary to have a MEC, a processing very close to the end user as possible. So why we are using this MEC in 5G? Because we need like several applications, as we see before, in particular for 5G connection, that you need the MEC or the processing close to the end user. You have energy efficiency and sustainability. I mean, you have to spend as less energy as possible here and process the information close to the end user to not consume like electricity or transmission to process information far away or to have data process handled far away. So also for efficiency, it's necessary this MEC in this 5G ecosystem. Also for bandwidth and haste, as you saw before, you don't need to connect to the core like very far away from your user. I mean, you connect it like very close to you. Also IoT, I mean, one of the main application or user scenario for this MEC is also the IoT. Integration and investment protection that can be integrated in 4G and 5G, protecting investment and facilitating the ultra reliable and low latency communication, as we saw before. And also for ultra low latency communication that is very necessary. So 5G and MEC are necessary. So if in 5G we want to achieve the goal of our 1 millisecond or 2 millisecond latency, for sure we need the MEC to process that information as possible, as close as possible to the end user. So here in this slide is just to show a little bit like our architecture in 5G. We have like this explanation from Mr. Raymond about the core, I mean, about the processing edge computing in a computing ecosystem. Here, I just want to show you a little bit like what are the functions that we have so far in our core. We can see here like different functions going from this network slice selection. One particular that we have here is the user plane function that is necessary to connect our BTS in 5G to the data network. and we need this session management function to establish the connection or to maintain the connection for this end user. So this one is not for you to remember all the function, but it's just to know, I mean, to show you that there are several functions that are working today in the cloud. They have been working, I mean, in a virtualized ecosystem, as we see before. And right now, these functions are working in a cloud ecosystem. And this is more or less like how it looks, all of these functionalities working on the 5G. So in a MEC system, we have like this component. I mean, we have something like a orchestrator, like the director in an orchestra. I mean, when you have music, making like the decision about what are the application, what are the service, how they are gonna connect over there, how to handle the infrastructure in that ecosystem, what is the complete MEC platform, and how are they managing all of this MEC platform. So this one is just to show you that from one side we have like this 5G system, and in the other side we have like this MEC system working over there. So when we are working on this MEC deployment in a 5G network here, we see like the main functionality from the 5G network, in particular focus on the control plane, they are still kept on the 5G core. And we have like these particular user plane functionalities that are working or deployed in this MEC system. So we can see here in this slide, I mean, it's just to remind you, like we have like this cloud, we have this edge cloud, we have 5G functionalities, and we have these MEC functionalities. So these functionalities of MEC could be deployed like in different areas. We can have like this MEC as we have here with the user plane functionalities very close to the base station, as we can see here. We have another scenario of this MEC functionalities working on this transmission or this on this transmission point, like located here. You still have your 5G functionalities, main functionalities here located in the core, but you have these user plane functionalities and these MEC functionalities working on this transmission point. We have also this, let's gonna say, aggregation in this network aggregation point here. As you see here, you have like the BTS here. You have this aggregation point for functionalities, for MEC functionalities located here, also with the user plane and the core network. And also there is another possibility to have these MEC functionalities that is working like very close to the core network. So as you can see here, there are like 4 main possibilities to deploy like this MEC. One of the, let's gonna say more important, or I think will be like the most important, is to have like this MEC and user plane functionalities very close to the site or to the BTS or G-Node B here in the very close to the end user. But anyway, you have like these 4 possibilities to deploy your MEC, as you can see on this slide. So you can have like different possibilities or different use case here. So you can have like IoT application deployed in this MEC server close to the base station here with all of these IoT devices here working on this MEC server. As you remember, this MEC is also working on the cloud, but in the edge cloud. Also, you have this MEC server with functionalities, as we saw in the previous slide, with autonomous vehicles like V2X communication, with all of this industrial internet or industrial application, where you are limited all of this to the office or to the company's network or to the company's area. Also, healthcare, virtual reality, augmented reality, or mixed reality for, let's gonna say, for gaming in particular. Also, you have these MEC functionalities limited, for example, for a retail, I mean, like a small selling or supermarket, is more a smart city. That is also like another kind of application, and also for smart energy. And also for all of this, you have like this smart farming, weather monitoring, using all of these IoT applications. So it's possible having or use this MEC use case for all of the scenarios that we have here. But anyway, when you see this and you see, oh, this is just, let's gonna say, PowerPoint that is beautiful with all of these applications. But anyway, we have like several examples. I mean, I just have like these two main, for me, like the two more interesting cases for all of this MEC deployment. One of the one, for sure, is the one of Rakuten, because you have heard a lot about this name here, in particular, because, you know, we have like this all-run deployment for all of them. But I think it's also like a good way to understand or to see all of this MEC ecosystem. As you see in this one, as you can see here in this slide, in the, let's say, in the old traditional way, you have like all of your functionalities here. You can have like these functionalities deployed somewhere in the edge, and you have like these BTS function, BTS sites located here. But when you start thinking about or working about Open RAN or virtualization or cloudification, you will try to move all of that traditional scenario, but a more flexible scenario. And that's what was Rakuten doing. So they deployed about all of this in this cloud ecosystem, as you can see here. And so they deployed all of that functionalities in a cloud for Rakuten. Is a, let's gonna say, a proprietary cloud developed by Rakuten with their team. I mean, working together with, for example, in this case for Nokia, for this central cloud. As you can see here, all the functionalities that we saw in the core part, located here in the cloud, in the proprietary cloud of Rakuten. You have something like regional cloud, putting some functionality, in this case, for example, user plane functionalities and the MEC deployed in this code server, using the principle of cloud. And in this edge cloud, like very close to the end user, they deployed this DU and CU. And very close to this, I mean, also like so in some other place, sorry, they put like all of this BTS part. So as you can see here, I think it's like a very good example of how they have deployed or used the central cloud, I mean, to deploy the main functionality for 5G, and the regional and the edge cloud to deploy like this RAN part, and also this user plane functionality from the core. So here, I think it's like a good example of putting together, or working together, cloud, central cloud or general cloud, and also the edge cloud working at the same time. But in this case, used by a proprietary or a private a Rakuten cloud, I mean, developed in working together with Nokia. And so here, I think it's also like another good example of all of this. For sure, we start here with the traditional deployment of all of this deployment with the traditional core, with this BTS and all of that, and the migration of all of this, but using this working. The most interesting here is working in a AWS ecosystem. As you know, this AWS is Amazon Web Services. So they are deployed, instead of putting or deploying a traditional core network using like a private network from their own, they decide to deploy all of these using this public cloud infrastructure, as you can see here in on this slide. So they deploy like these core functionalities in AWS, for sure, with the help with the Nokia, to deploy all of these 5G functions here, but in this cloud from AWS, in a regional data center, in a metro data center owned by AWS, using AWS local zone. So here they deployed CU, user plane functionalities, and the MEC. this from Nokia, but anyway, working in a public cloud by AWS. And so here in this, let's gonna say this product is AWS output, sorry, by using Altostar and Maven agreement. So they have like this deal deployed in AWS that is essentially a server located here. And so they have like this 5G open run here and 5G, let's gonna say traditional run here to have all of this. I mean, the most interesting thing about these two slides, I mean, the previous one with Rakuten and this one with this one, with this, is with the Rakuten, you deployed all of these 5G run, 5G core and 5G run in a private cloud. And here you use this, you deploy that on a public cloud. So these are like two cases that are very interesting to know, like how they have worked with all of this. Anyway, for this public deployment, it's not something like very popular right now because depends a lot of things, depends on how much cloud or server you have of cloud in your country. For example, this one, as you see here, it was deployed in USA. That, you know, the coverage of AWS in USA is very good with regional and local areas over there. So it's very good. So it's possible to do it over there. Maybe in other country is not possible. But anyway, it's good to know, like, it's a good reference case that we need to understand and to know that it's possible to make it in a public cloud like it is here, or in a private cloud like is in the Rakuten case. So this other, beside looking at all of that, is this report is from the EDNO report. It's an European telecommunication organization that they make like this report about what they expect to do about this edge deployment, about this edge cloud computing deployment, like in the following years. As you see, for 2023, they announced like this. They expect to do all of this. For 2023, they have all of this announcement of deployment of edge in all around the world. Commercial, for sure, the number are less, but at least this shows you show us a little bit like how is this edge computer or MEC deployment going around the world. And this one is how are the enterprise expect to spend on public edge computing service by region worldwide between 2019 and 2026. So like in all of our region from North America, Asia, and all of our areas. So this is the money they expect to spend on edge computing. So it's something that is a market that is still, I mean, it's still, they are still growing, but there are a lot of possibility to grow a lot more about that, because there are several providers working about all of this. I mean, if you just check the page from Nokia, Huawei, Samsung, Ericsson, or whatever of those companies, all of them, they are providing MEC. Also, the people from Red Hat, they also have this OpenShift solution from their side, where they are working together also with this other telecommunication provider to provide this ecosystem to deploy this cloud and MEC deployment, to have these core functionalities and run functionalities working on this cloud. So it's something good to see what is going on with all of these providers. In this one, I think I will share the link because I don't think you will have like a lot of time to check all of these slides. But anyways, all of the latest news about MEC. So in this one, I think this document is very good. I will share anyway this link in the YouTube. You know, this Azure Open RAN Academy, they publish all of this presentation in YouTube, and in that YouTube page, I will share this link so you can have it and you can check with time. I mean, all of this. So in this one is a very good documents, and they mention like the 10 trends reshaping MEC in 2024, including Edge AI, 5G, IoT, Edge Analytic, blockchain, and more. So this is a good document to check about what they are expecting to do in the following years about all of this. This April 2024 is an information from the ETSI where they mention about the completing of the phase 3 of the MEC, as you remember, like in 2022, and what will be the focus for phase 4 of this MEC in the following years, including the MEC security enhancement. This MEC deliveries, they show you about terminology, use case, framework, reference, and some presentation that is also good to see. MEC application slide studies, quality of service measurements, and sensor sharing APIs by ETSI. This one is also interesting if you are checking or if you are studying about API, about how they can provide service and connection to third parties. And so this document is also very good. So I think the main concept here is in the ETSI, you just write ETSI, multi-access edge computing, and you will go to all of these pages. Anyway, I will share this in YouTube so you can have it like, you can check it later, but I think it's a very good way to understand what is going on with all of this MEC activity worldwide. So what is the future of MEC here? So we are expecting to have support for all of these new applications in 5G and for future use cases in 6G, including intelligent video, augmented reality, virtual reality, mixed reality, and all of those realities, and this autonomous vehicle and V2X communication. The future of MEC, there are also considerations about cost, about how to optimize all of these costs, about MEC use, about how we are going to use our resources to provide the better benefits to the end users. Also, there's some concerns about in the future about how to optimize all of this energy. How we're gonna use in the best possible way or our processing, if we are going to process our information locally, or if we are going to process that information in the cloud or in the edge cloud. There will be some enhancement in all of this standard and specification. For sure, we have right now, we are on phase 3 on the MEC standard. We will go for 4 in the following years. Integration with all of this 5G and beyond 5G evolution, and how we will integrate with the 6G in the future. How we will integrate this MEC with AI. Today we're doing some basic integration. We're still in the first step with AI, and we expect to have more applications or more solutions with the AI that could be integrated or could be deployed with the MEC. Also, ubiquitous network and computing. With all of this capacity of processing that we have every time about processing like everywhere, about all of this, getting a capacity of having the possibility to process information like everywhere. So this MEC is also possible going to the end user. To have like this MEC processing at the user device without having to go to the core. So as you can see here, we have like this future of what we expect about this MEC, about how will be the future for the MEC in the following years. So now I think we are going, and for sure the integration with AI, and so I think we are going to the final parts of this presentation. Is about the final consideration for MEC. As you see in the presentation, we have multi-access edge computing. They received like this renaming like in a few years ago, and it's an standard specified or defined by the ETSI. MEC is a very important component in the evolution of 5G and 6G network, offer advantage in terms of latency, bandwidth, energy, and also protection or sovereignty, protection, limitation by country or by company, depending on our needs, extends to different kind of application as we see, making a critical component of future telecommunication and infrastructures. Anyway, we have challenges, we have cost and complexity that could need to be managed by all the players in these new games. And we have here like very good reference. I mean, we have like this Etsy reference for MEC, just write Etsy and multi-access edge computing. And also in the 3GPP page, you have something for the edge computing that is also, they have like very good documents about this edge computing.